Good morning children. I am ready with the next video, force and pressure part 2. What is pressure? Pressure is defined as the force per unit area or thrust per unit area. Pressure is equals to force per unit area, where pressure is measured in pascals, force in newtons and area in meters squared, which are the SI units. What is thrust? Thrust is the perpendicular force to the surface. Here you see the feet is perpendicular to the ground. Now pressure is directly proportional to the force applied and indirectly proportional to the area under contact, which means keeping the area constant, more is the force, more is the pressure, and keeping the force constant, more is the area, less is the pressure. Here is an example of a knife with a larger area under contact called a dull knife, and a knife with a lesser area under contact called a sharp knife. Now, in which case do you think the pressure will be more in case of sharper knife? Now, some more examples. In the first case, you see a person when poked with a finger on his arm, the finger doesn't pierce inside the skin. Whereas when it is poked with an injection needle, it pierces inside, which means in case of the injection needle, the area under contact is less, hence the pressure is more. Second case again, when the mouth of the hose pipe is held with a finger, the area under contact is less, hence the liquid pressure is more. Now some numericals. Here you find Bobby is keeping a box with the base as 2 meter into 1 meter. Weight of the box being 60 Newton and the area being 2 meters per meter square. The pressure is equals to 60 by 2 is equals to 30 newtons per meter square. Newtons per meter square is equals to Pascal. Hence the pressure is 30 Pascal. Next is the case when the same block is kept with area under contact with the ground as different. In first case, the area under contact is calculated as 200 centimeters square, which is equals to 0.02 meters square, meter square being the unit of area in SI unit. And in second case, the area being 800 centimeters square, that is equals to 0.08 meters square. But the force in both the cases is same, which is the weight of the block 5 kg into 9.8 meters per second square. 9.8 meters per second square is the acceleration due to gravity, which is equals to 49 Newton. Now, the pressure in first case is calculated as 2450 Newton per meter square, whereas in the second case is 612.5 Newtons per meter square. Thus, we conclude that when the surface area under contact is more, the pressure is less. Now, here are the cases of pressure applied by liquids. In the first case and last case, the vessels are not enclosed. That means the vessels have a free end. When 3 holes are made in the body of the bottle at different heights, the lowermost hole ejects water with the greatest pressure, which means pressure increases with depth. Whereas in the last case, when the holes are made at same height, the pressure is equal in all directions. Hence, at the same depth, the pressure is equal in all directions. Whereas in the second case, the pressure is in an enclosed vessel is equal in all directions, undiminished. This explains why the dams have a thicker wall at the bottom, because the weight of the water column is very high at the bottom, which requires a broader base to decrease the pressure. Also, the reservoirs of water and the city tanks of water are higher than the highest building in the locality, so that each building has a good water pressure. Now, atmospheric pressure. What is atmospheric pressure? It is the pressure of the air column above us, in simple language. Now this is nearly equals to 2 elephants' weight on our head, rather on 1 meter square. Now that is truly a very big weight to sustain. But because our body has nearly equal pressure from inside, it sustains this pressure. Rather, the pressure of air is same in all directions. Now the surface of the earth, the pressure is 1 atmosphere, which means the gravitational force on 1 meter square area is 1 atmospheric pressure. This is a Medberg's hemisphere. Now here you see the 2 spheres which are glued with the grease, and the air is sucked out of them, has so much of pressure from outside that they cannot be separated very easily. It requires many horses to pull them apart. Some real life uses of atmospheric pressure. This is an example of a syringe where when the piston is pulled up, a low pressure is built inside, which allows the atmospheric pressure to gush the liquid in. Same is the case with the straw. When a person pulls out or sucks out some air from the straw, a low pressure is created inside, which allows the atmospheric pressure above the surface of the liquid to push the liquid inside. These are the instruments to measure atmospheric pressure, known as barometer. The first one is the earliest barometer made, and the next one is the barometer which you usually find in the labs. Now the first one shows that 760 millimeter of Hg is equivalent to the atmospheric pressure at sea level. Now, can you identify this instrument? This is a pressure gauge which you often find in the cycle repairing shops, where it measures the pressure inside the tires, or in the doctor's chamber, which measures the pressure of a human body. Thank you for patient hearing, children.